Hello everyone. In this video, let us see some 100 practice bits related to quantum mechanics, useful for set exam. The first one, Bohr postulated in his model quantization about angular momentum. So, the second postulate is nothing but about the angular momentum itself only. Next, the angular momentum of electron in hydrogen atom can be possibly be, what is the second postulate says? Angular momentum is equal to h by 2 pi, right? No two electrons will have all the four quantum numbers equally. This is the statement given by Pauli's exclusion principle. According to Bohr's principle, the relation between the main quantum number n and the radius of orbit is r proportional to n square. The hydrogen atom in a D state is in D state. For this state, the value of m are -2, -1, 0, 1, 2. Any particle in motion, whether charged or uncharged, either it is charged or uncharged, is accompanied by matter waves. It is accompanied by matter waves. Next, the Davison-Germer experiments, what it relates to electron diffraction. They proved the electron diffraction. Energy in quantum state varies directly with frequency. Energy directly proportional to frequency. What is the formula? E is equal to h nu, no. So, E proportional to nu. Right? Frequency, when nu is the frequency. The wavelength of lambda associated with a particle of mass m moving with velocity v is de Broglie wavelength. Lambda is equal to h by mv. Right? Now next, the de Broglie hypothesis is associated with wave nature of all material particles, because de Broglie strongly said that a moving particle is associated with wave or a wave packet. So, de Broglie hypothesis is associated with wave nature of all material particles. Okay. Now next, neglecting the variation of mass with velocity, the wavelength associated with electron is proportional to, okay, wavelength with respect to energy, he said, no, 1 by h by under root 2me is the formula with respect to energy. So in last video, we discussed about the formulas, part 2 you see, okay, de Broglie formulas. So this is root e or e to the power of 1 by e to the power of 1 by 2 or e to the power of minus 1 by 2. Now matter waves, they show diffraction only. If a charged particle of mass m is accelerated through a potential difference, then de Broglie wavelength, how we will write? Under root 2m ev means 1 by v to the power of 1 by 2 or v to the power of minus 1 by 2. According to Schrodinger, a particle is equivalent to nothing but wave packet. Of the following moving with the same velocity, the one which has the largest wavelength is photon. Now next, of the following having the same kind, means he gave the four options, in that answer is photon, the largest wavelength. Here also the same kinetic energy which has longest wavelength is electron. The expression psi r comma t whole square stands for what we say? Probability density, position probability density. Expectation value of momentum P is, how we will write the expectation value? Integral psi star in between the momentum P psi. How we will write? Integral psi star momentum P psi d tau. Here, P operator I am writing h cut by I into delta. P operator I wrote. Now next, the traveling harmonic waves which have constant magnitude at great distances and for which the normalization integral diverges represents free particles. The phase velocity and group velocity of de Broglie wavelength in space. The relation between the phase and group velocity for a de Broglie wavelength in free space. If c is the speed of light, then the formula Vp Vg equal to c square. Next, now only we wrote no the de Broglie wavelength in terms of temperature. Sorry, before I wrote in terms of energy, no? Now temperature h by under root 2m kt. Which pairs of phenomena illustrates the particle accept of wave-particle duality? Photoelectric effect and Compton effect only. Okay, which give rise to the wave-particle duality. Means here particle will have, matter will have particle nature as well as wave nature. Okay. Or light have particle as well as wave nature. Now next, an electron of mass m, charge E, which is at rest, he said he is accelerated by E. Now he is asking to find the rate of change of de Broglie wavelength with respect to the time t is minus h by t square, where h Planck's constant, small e charge of the particular charged particle, e energy, t time. The uncertain relation holds for uncertainty is for microscopic particles only, not macroscopic. According to uncertainty relation, the minimum uncertainty in the velocity of electron orbiting around the nucleus of radius r. How we will write? So, according to uncertainty relation, velocity of uncertainty in velocity is h by 2 pi m r. Right? Remember the formulas. Now next, the uncertainty relation cannot hold for the following: linear momentum and angle. It is not holds good for linear momentum and angle. According to wave mechanics, free particles can possess continuous energies. The energies of particle in box, I said in the part 2 video, n square h pi square h cut square by 2m l square, most important. In place of l, there we wrote a square. I think you remember. In the case of potential step of height v0, if a particle of energy E less than v0, then the transmittance is 0. The 0 point energy, already we discussed in part 2 video, half h cut omega. The uncertainty in the location of the particle is equal to the de Broglie wavelength. Uncertainty is equal to the de Broglie wavelength. Then uncertainty in velocity, as usually v. Okay, uncertainty in velocity is v. Okay, uncertainty in position is de Broglie wavelength. Can we derive this? Let us see, no? Here, let us derive this. Uncertainty in position is equal to de Broglie wavelength h by m delta v. Right? So, delta x, delta v, h by m. Right? Now, next, or I can write it as, now, uncertainty principle delta x, delta p is equal to h by m. This I am writing delta v. Okay. Now, delta v means what? Delta x, delta p, h by m, delta x by delta t. Okay. So, now, momentum we want. Okay. So, momentum, if we simplify, it will be equal to the velocity itself only. Momentum means what? M into V only, no. Let us substitute no delta V. That is equal to H delta T by M delta X. Okay. Here M is there. Now here there delta X by delta T V. If we simplify, we get V. The Ehrenfest theorem is in last video we derived this. Once check my part 3 video, you will get this answer. The Ehrenfest theorem, the theorem is d by dt average R equal to 1 by m average P, momentum, and d by dt average P equal to minus average dv dou V by dou R dash. Okay. The particle is in a cube box with infinite hard walls whose edges are ABC. The wave function of particles. This formula is most important. Okay, remember this formula. Psi nx ny nz equal to 2 root 2 by root ABC, sin nx pi x by a, sin ny pi y by b, sin nz pi z by c. This is the formula for particle in a cube box of infinite hard walls with the edges ABC. Right? Now next, a particle is in cubic box with infinitely hard walls. He is asking here, we find out the wave function. Here he is asking eigenvalue. So the eigenvalue is pi square h cut square by 2m nx square by a square plus ny square by b square plus nz square by c square. This is also important formula, remember. The number of zeros in probability of finding the electron as a function of distance from nucleus in H atom in a quantum state NL is n minus L minus 1. Next, if the oscillator is in its normal state, then probability of finding the particle outside the classical limits is 16% only. Eigenfunction of Hamiltonian operator AU421 plus BU420 plus CU410. Now 421 420 410. Okay. Now next, the spin angular momentum of electron is always same, equal to h by 4 pi. For a particle of energy E in a 1D square well of depth V0, centered at the origin and a width A, the bound state wave function for large negative x is in the form of e to the power of minus I by h cut under root 2mex. Now next, the degree of degeneracy for three-dimensional isotopic harmonic oscillator 1 by 2, n plus 1, n plus 2. This is also important, remember. Now next, a rigid diatomic molecule is free to rotate in a fixed plane. The rotational energy eigenvalues are given by formula is h cut m square by 2i. Which of the following is eigenfunction of Lz? E to the power of I pi is the eigenfunction of Lz. Now similarly, here in scattering of a particle from the spherically symmetric potential, the conserved quantities are E L square Lz. L, angular momentum, E, energy. In partial wave analysis, the expression for total cross-section of scattering, remember this is scattering formula, most important, 4 pi by k square summation L 2L plus 1 sin square dou L. Now next, in partial wave analysis, scattering amplitude is 1 by k summation L equal to 0 to infinity 2L plus 1 PL cos theta e to the power of I dou L sin dou L. Now next, the optical theorem relates the total scattering cross section to the scattering amplitude in forward direction. Expression for this theorem 4 pi by k Im f of 0. Now next, for the rigid sphere of radius a, the scattering cross section at low energy is 4 pi a square. Okay, what is the scattering cross section for rigid sphere? 4 pi a square. Okay, the scattering cross section in forward direction with amplitude is 4 pi by k Im f0. This is scattering amplitude. Now this formula is cross section of scattering. Okay. Now next, which of the following is not fermion? 4 options he gave: electron, muons, neutrons, photon. Photon is not fermion. Now next, which of the following is not boson? Neutral helium particle, alpha particle, photon, muons. Muons is not boson. Now next, the value of Lx r square 0. Explicit, these are also important. Remember these formulas. Explicit differential operator representations of Lx in spherical polar coordinates is I h cut sin pi dou by dou theta plus cot theta cos pi dou by dou pi. I h cut sin pi dou by dou theta plus cot theta cos pi dou by dou pi. Explicit differential operator representing Ly. This is Lx, now Ly. I h cut minus cos pi dou by dou theta plus cot theta sin pi dou by dou pi. Okay. In place of sin theta minus cos theta. In place of cos pi, sin pi. Now, the wave property of large massive objects is not observed because their momenta are too large. Right? A proton and an alpha particle has same kinetic energy. If the mass of alpha particle is 4 times that of the proton, how do their de Broglie wavelength changes? Compare, he say. So, lambda of proton equal to, it becomes twice the lambda of alpha particle. Remember this relation, important. If the Planck's constant h is greater than the Planck's 6.625 to 10 to the power of minus 34 joule second, then what happens? The uncertainty relation will hold also on macroscopic scale. Actually, uncertainty means in the below bit only we said it is for microscopic. Now, if it is h is greater than this value, then it also holds for macroscopic scales. The electrons are emitted from metal surface when light is falling on it has minimum energy or work function also you can say. The energy of photoelectron in photoelectric effect, energy changes the frequency of the light itself, no? Now next, the quantum theory indicates, what does the quantum theory indicates? Wave nature only. The only moving particles having wave character. A particle is associated with wave packet, that the quantum theory indicates. A wave packet corresponding with a moving particle has same speed of particle. Wave packet speed will be equivalent to the speed of the particle. Remember this, most and most important. For the narrow wave packet of a particle, position can be determined. If a wave packet is narrow, easily you can determine the position. If we take a big well, can you determine the position easily? Impossible, no. So if it is narrow, we can determine the position easily. An atom emits a photon when one of its electron suffers a transition to a quantum state of lower energy. Next, with increasing quantum number, the energy difference between successive energy level decreases. The quantum state or energy of an atom depends on principal quantum number. The uncertainty relation applies to pair of dynamic variable operators corresponding to which do not commutate. In red pen, what I wrote is the options which is asked in the bits. In dispersive medium, group velocity of wave group is always less than phase velocity. This is the answer, red pen. Now, blue pen is the question. From the quantum theory of observation and measurement, if a system is in certain state for time delta t, if it is in certain state for time delta t, then the energy will be h cut by delta t. Delta t greater than or equal to h cut, no. So, energy will be equal to h cut by delta t, that's it. Okay, delta t greater than or equal to h cut. So, delta E is equal to h cut by delta t. That only we wrote using the Heisenberg uncertainty principle. Right? Now, next, uncertainty in quantum mechanical measurement is due to interaction between an animate or inanimate observer and observed. The Davison-Germer experiment confirms wave nature only, wave nature. Electrons are having wave nature. Before Davison-Germer experiment, electrons are particle in nature, they said. But this experiment proved electrons will have wave nature. According to de Broglie hypothesis, what de Broglie hypothesis say? Particles have wave-like characteristics only. Remember this, the major concept is every moving particle is associated with wave packet. That's it. The de Broglie wavelength of a proton alpha particle are in ratio 4:1. Remember, this is also most important. The proton and alpha particle are in ratio of 4:1. The relation between group and velocity, phase velocity, most important relation. Vg equal to Vp minus lambda dVp by d lambda. G for group, P for phase. Vg equal to Vp minus lambda dVp by d lambda. Lambda, wavelength. Heisenberg uncertainty principle, not observable for microscopic objects. The properties of gamma rays due to which it is used in gamma ray microscope is minimum wavelength. A particle of rest mass has a kinetic energy k, then de Broglie wavelength hc by under root k into k plus 2 m naught c square. The angular momentum of atomic electron quantized in magnitude and direction both. Right? Now next, a hydrogen atom remains in its ground state when electron is in its first orbital. For spherically symmetric probability, cloud of electron is orbital quantum number is 0 for cloud of electron. The electron orbit in a ground state hydrogen atom is in circumference equal to de Broglie wavelength itself. Okay. This we call it as de Broglie wavelength for Bohr's second postulate, we will say. The densest part of the probability cloud occurs at a radius proportional to n square. If the width L between two sides of one dimension potential well is decreased to a smaller width L, then energy difference between consecutive energy levels increases. The Pauli exclusion principle states that particle with half integral spin cannot exist in the same state, means in such a way. Every time the spin will be in such a way. Okay. The operator Lx, Ly, Lz are Hermitians. The expectation value of Hermitian operator is always real. If the particle is in spherically symmetric field V of R, the Hamiltonian H commutate with L square and Lz. Okay. Now next, the explicit expression for operator d by dx plus x whole square is given by d square by dx square plus 2x dy dx plus x square plus 1. The explicit expression for operator I h cut del plus a of r whole square is given by minus h cut square del square plus 2 I h cut a dot del plus I h cut del dot a plus a square. The explicit expression for operator L minus m L plus m is given as L square minus m square plus Lm minus ml. The commutation relation for operator x and dx gives minus 1. The commutation relation for I h cut del and a of r gives I h cut del dot a. We define ladder operator L plus equal to Lx plus ILy. L minus is equal to Lx minus ILy. The value of half L minus L plus L minus L plus is L square minus Lz. The inequality f dot g whole square less than or equal to f comma f g comma g is known as squarce inequality, most important. The commutation identity L1 plus L2m is L1m plus L2m. Next, the exact value of L plus L minus Lx square plus Ly square minus I Lx comma Ly. Prepare this, most important. The value of Lx L square 0. Many times he asked in the set exam. The value of h comma Lx 0. The value of Lx Ly I h cut L2. Schrodinger wave equation is a wave equation governing the behavior of matter waves itself only. In case of more than one linearly independent wave function belonging to same energy, the level is said to be degenerate. What is degeneracy? One linearly independent wave function belongs to same energy, E levels. The wave psi equal to a e to the power of ix represents wave traveling along positive x-axis. Now the 100th one, the existence of 0 point energy for a linear harmonic oscillator is a consequence of uncertainty principle. So thank you for watching my video. If you like my video, please subscribe it, share it, like it. Yours, Reshma Physics. Stay with my channel to receive more practice bits related to the quantum mechanics useful for DSS set exam. Thank you.